Okay, everyone, please pay attention. So, force acting on mass kept at O. Force acting on mass kept at O. So, F net will be, now this will be gm square upon A square. We are talking about these two, plus gm square upon 2A whole square, plus gm square upon 4A whole square, plus gm square upon 8A whole square, and so on. It will continue till infinity. So what we are observing here, it becomes gm square upon A square. This is common. 1 plus 1 by 4 plus 1 by 16 plus 1 by 64 plus and so on. Now this part is basically a GP, geometric progression. This is an infinite GP. So sum of that infinite GP will be, pay attention, so gm square upon A square. The formula for S is A upon 1 minus R. S is equal to A upon 1 minus R, where A is first term, which is 1 here, upon 1 minus R is common ratio. Common ratio is the thing which you get. Basically, if you are getting second term, you will be getting second term if you multiply first term by the common ratio. So common ratio here is 1 by 4. Alright. So 1 into 1 by 4 becomes 1 by 4. 1 by 4 into 1 by 4 will become 1 by 16. 1 by 16 into 1 by 4 will be 1 upon 64, and so on. So this becomes further gm square upon A square. 1 upon 1 minus 1 by 4 is 3 by 4. So that becomes 4 by 3 gm square upon A square. That is the value of F net. That is the value of F net. So F net comes out to be this much, 4 by 3 gm square upon A square. 4 by 3 gm square upon A square. Alright, please note. Please note, everyone. Now let us move further. The next important topic in this chapter, for school point of view also and for computation point of view also, is acceleration due to gravity. Acceleration due to gravity. Okay. So acceleration due to gravity is nothing but G. We have talked about this G when we were solving questions in previous classes, specifically in motion under gravity, when we talked about in rectilinear motion, right? So acceleration due to gravity is G, and how to calculate it and how it varies, we'll be talking about this. Okay. So if any object if any object is allowed to fall freely near Earth's surface, if an object is allowed to fall freely near Earth's surface, then its acceleration is called then its acceleration is called acceleration due to acceleration due to gravity. Okay. So if an object is allowed to fall freely near Earth's surface. Now try to understand. Suppose this is Earth. Okay. This is Earth. Don't worry too much about its shape. Now suppose the object is very close to Earth's surface here. So m will be the mass of object. Capital M will be the mass of Earth. Let me call it ME. E for Earth. Radius of Earth is RE. Radius of Earth is RE. The gravitational force acting between Earth and object. The gravitational force acting between Earth and mass small m. So F will be G MA small m upon RE square. Equation number 1. Okay. Hence, acceleration of small m. Hence, acceleration of small m. So A, and that will be F by m. So A will be G ME small m upon RE square upon small m. So this small m got cancelled. So A will be GME upon RE square. A will be GME upon RE square. The acceleration given by equation 2. The acceleration given by equation 2. The acceleration given by equation 2 is called acceleration due to gravity. The acceleration given by equation 2 is called acceleration due to gravity. It does not depend on it does not depend on mass of falling object. Mass of falling object. So basically it is same for all the objects of all masses, right? So whether you are dropping a mobile phone or pen or a stone or any valuable object or invaluable object, acceleration due to gravity will be same. acceleration due to gravity will be same. All right, and the symbol which is used is special, and that is called G. So G is equal to GME upon RE square. Okay, the value of G, comes out to be G is equal to 9.78 meters per second square, which is also taken as 9.8 meters per second square, which is also taken as, in fact, we have used also as 10 meter per second square. Okay, so this we do for simplicity. This we do for ease of calculation. All right. So G is equal to 9.78 is equal to 9.8, and that is also equal to 10. That we do, that we calculate, or that we use for sake of simplicity. All right. Any doubt, any question? Now, if you are studying this, there are most likely chances in school that they talk about acceleration due to gravity and variation in acceleration due to gravity due to various parameters. Variation in acceleration due to gravity due to various parameters. They can also talk about that. So if they ask, you can simply answer. There is no big deal in that. Okay. So how it varies, we will be talking about that also just now. Let us move further. Variation of, please write, acceleration due to gravity. Variation of acceleration due to gravity. So how basically G changes? That's what we are going to talk about. The value of small g, how it changes, that we need to discuss, that we need to find out. Number one, variation due to height. Variation due to height. So how g will vary if we go to height? All right. So let us talk about that. So suppose again this is our earth. This is our earth, and we want to know that how or what will be the value of g at some height h above the earth's surface. So this is RE, this is ME because this is the earth only, and our object is here small m. So wherever you want to calculate the value of g, what you need to do, you need to assume that small m is kept at that point. All right. Now this point should be at height h. This point should be at height h. And as we are using word height, that's why we are using symbol h. Okay. So basically we are trying to find that how much will be value of acceleration due to gravity at point P, which is height h above the earth's surface. Okay. So please write, in the given situation, we need to calculate, or we are trying to calculate, value of g at height h above earth's surface. At height h above Earth's surface, right? So if Fh is the force, if Fh is the force acting on mass m, if Fh is the force acting on mass m at height h, then so Fh is equal to G me small m upon Re plus h whole square. This will be the force. This will be the force. Okay. So Fh is equal to Gmem upon Re plus h whole square. Now this Fh will help us in getting Gh. Hence acceleration due to gravity at height h. Hence acceleration due to gravity at height h. So Gh is equal to Fh upon m, and that will give us Gh is equal to Gmem upon Re plus h whole square divided by m. So this m and this m gets cancelled. So Gh comes out to be Gme upon Re plus h whole square. Gh is equal to Gme upon Re plus h whole square. Okay. This also can be used as the formula, but we don't use this formula in this way. Though it can be used, but we don't use it this way. So what to do? Let us see. Let us see. So we are going to write this further as H is equal to GME into, or let it be in the bottom denominator itself. RE I am taking as common, and this will be 1 upon 1 plus H upon RE whole square. It will become like that. Again, pay attention what I have done. I have taken RE as common. So when you divide RE by RE, it will be 1. And when you divide H by RE, it will be H upon RE. This is H upon RE whole square. Alright. Now further it will be GH is equal to, now this GM upon RE square, if you see, that is acceleration due to gravity at Earth's surface. So let me call it as GS, S for surface, upon 1 plus H upon Re whole square. So you can use this formula also, though we don't use it. But you can use formula in this way also. Okay. So what are we going to do further? We'll solve. GH will be GS. Now I am going to write 1 plus H upon Re, and this will be minus 2. I have taken it from denominator to upside. When I have taken it upside, it will be power minus 2. Now I am going to use one binomial expansion. Binomial expansion. So that binomial expansion will be 1 plus x to the power n. Remember how it is used. 1 plus x to the power n, and that will be 1 plus nx plus n into n minus 1 upon factorial 2 into x square and so on. Okay. So this formula is used, this expansion is used when x is very small. So this can be used when x is very small. Okay. This expansion is called binomial expansion. So we are going to use this in this formula in this question. So GH is equal to GS into 1 minus 2H upon RE plus other terms will be there which will become negligible. And what is condition here? Let me tell you. When, because we need to ensure that x is very small. What is x here? H upon RE. H is much less than RE. This is the criteria which we need to fulfill. What does it mean? That means the height of point where we are calculating g, it should be very small as compared to radius of earth. Now just to tell you, radius of earth is 6400 kilometers. Radius of earth is 6400 kilometers. Now as compared to 6400 kilometers, 2 kilometer, 3 kilometer, 4 kilometer, 5 kilometer, 10 kilometer, all these distances are very less. Again, just to give you perspective, height of Mount Everest is 8848 meter. That means 8.8 kilometer. So from this perspective, even Mount Everest is negligible height as compared to the radius of Earth, because radius of Earth is 6400 kilometers, right? So even if we are going up to the peak of Mount Everest, the height consideration of this formula will be valid. Height consideration of this formula will be valid. So when we are going to solve this further, it will be GH will be GS into 1 minus twice H upon RE, because other terms will be negligible. Other terms will be negligible. So this will be the formula which we are going to use, provided height of point P is very less from Earth's surface. Okay, so let me call this as equation 3. So equation 3 gives acceleration due to gravity.
So the other terms are not considered
Yeah, because those
because
terms
they
will
are
be negligible.
okay, sir.
Understood?
Yes, sir.
Equation 3 gives acceleration due to gravity at height h above Earth's surface when h is very small. When h is very small. Please note and pay attention. Noted, everyone? Good. Question.
So please prolong.
Find find acceleration due to gravity at height 5 kilometer above Earth's surface. Please calculate and tell me. Okay. GS you need to take as 9.8 meters per second square. Okay. GS means acceleration due to gravity at surface of Earth. Please calculate and tell me the answers. All right. This will be 9.8 into 1 minus 2 into h. H is 5 upon RE is 6400. Both are in kilometers, so kilometer will get cancelled. So that becomes 9.8 into 1 minus 1 upon 640. That will be 9.8 into 640 minus 1 upon 640. So this will be 639 upon 640. Okay. This will be so this value comes out to be 9.78 meters per second square. How many of you are getting this? 9.78 meters per second square. Okay, good, good. So the point which is to be noted or key takeaway from this question as well as the previous derivation is, as we go above the Earth's surface, value of G decreases. As we go above,
Sir,
yes.
how did you get the value of RE?
What I did, I took a meter scale and then I started from Vasco da Gama and I took a ship and you were holding that another end of, and then I traveled all the way across Earth. Then we got circumference. After finding circumference, we used 2 pi r is equal to circumference, and then we got r is equal to 6400. Remember? Hello? It is a value which is given to us. Neither you can measure it nor I can measure it. All right? Hello?
And then how did you get the value 6400?
Once I was a kid like you, I memorized the value at that time. Okay. My teacher told me that radius of Earth is 6400 kilometers, and I remembered the fact. Okay. Hello. Then I
Okay,
asked
sir.
him the same question, sir. How did you get this? Then he told me the same story. Okay. Hello. So as we go above Earth's surface, value of G decreases. I think they went up to space and used parallax method. Aradhya, think about the question. All right. Very nice. See, if you talk about Earth, Earth is not a uniform sphere. All right. So there are many approximation in calculation also. Many approximation, not just one, many. All right. So as we go above Earth's surface, value of G decreases. So this was variation due to height. Now next is variation due to depth. Variation due to depth. So how to find value of G inside Earth and how it changes, we have to calculate that, we have to find that. We'll do that. We'll do that as a society and as a team. Pay attention, everyone. So again, we need to draw Earth. So this is the Earth. Now we need to calculate G at point, let's say Q, which is inside Earth. So what I'm doing, I'm considering a point Q inside, and the depth of that point is D. I'm using D so that you know that this point is inside the depth. Okay. H is for height, D is for depth. All right. So what we are doing, we pay attention everyone. The full radius of Earth is RE. Radius of this point will be, because depth is D, so this will be RE minus D. This will be RE minus D. All right. This will be RE minus D. Okay. Now suppose if total mass of Earth is ME, mass inside will be this much, and suppose that is M in. That is M in. Okay. So let us write further. To calculate value of G inside Earth at point D below Earth surface, at point D below Earth surface, to calculate value of G inside Earth at point D below Earth surface, assuming a point mass M kept at point Q inside Earth. Inside Earth. Now the point which is to be noted is we have assumed it. We have assumed it, and we as a scientist, as a student of science, we can assume anything. Okay, so to calculate the value of G inside Earth at point D below Earth's surface, assuming a point mass M kept at point Q inside Earth. If F is, or FD is the force acting on mass M, then so FD will be nothing but G. Now pay attention. M in into small m upon RE minus D whole square. Because only the mass which is inside the sphere, which sphere? Orange sphere. Only the mass which is inside the orange sphere is going to exert force on point mass. Rest won't be exerting any force. Rest won't be exerting any force. So FD will be Gm in into M. FD will be Gm in into M upon Re minus D whole square. Now how much is the value of M in? How much is the value of M in? So for that we are going to have separate calculation. Now pay attention everyone. In total volume, so in 4 by 3 pi r e cube, how much is the mass? Me. Okay. In 4 by 3 pi r cube, mass is me. So in unit volume, mass will be me upon 4 by 3 pi r e cube. Correct. So in inside volume means how much? 4 by 3 pi r e minus d whole cube. How much will be the mass? So that will be mn. So this mn will be nothing but mass per unit volume into volume. And volume is how much? 4 by 3 into pi into re minus d whole cube. So this will be the value of min.
So can you please explain again what you did?
Huh?
So can you please explain what you did with 4 by 3 pi r?
Okay, listen very carefully. What I am saying is in total volume of earth, which is how much? 4 by 3 pi re cube. So in 4 by 3 pi re cube, mass is me, correct? So in unit volume of earth, unit volume, how much will be the mass? So that will be me upon 4 by 3 pi re cube, because mass by volume will be density. So how much will be the mass in the inside volume? How much is inside volume? It is 4 by 3 pi re cube. So m in will be mass per unit volume into volume inside. Understood?
Yes, sir.
Understood? Yeah. So m in comes out to be this 4 by 3 pi cancel. So me into re minus d whole cube upon re cube upon re cube. So this will be the value of m in. So let me put it here. So f d will be g into m in. Now how much is m in? me into re minus d whole cube upon re cube into small m upon re minus d whole square. Pay attention. This is going to cancel this. This is going to cancel this. So FD comes out to be G ME upon RE square into RE minus D upon RE into M. So this is FD. So G at depth D will be FD by M. So that will be GME upon RE square into 1 minus D upon RE into 1 minus D upon RE. Now GME upon RE square, this is nothing but GME upon RE square is nothing but G surface. So GD is equal to G surface into 1 minus D upon RE. So let me call this as equation 2. Please note everyone.
Sir,
Yes.
so could you please scroll up?
Is it okay?
Yes, sir.
Okay.
Thank you, sir.
Okay. Noted, everyone? Noted. Good. Now questions. Find depth. Acha, from here also you can notice star point that value of G decreases as we go below Earth's surface. Value of G decreases as we go below Earth's surface. Okay. So whether you go up or below Earth's surface, value of G decreases in both cases. Value of G decreases in both cases. If you want to see the diagram will be like this. Like this. So maximum value of G is at Earth's surface. Maximum value of G is at Earth surface. Beyond that, whether you go up or go down, value of G decreases. Value of G decreases. Okay. Okay. So the question was find depth below Earth's surface. Find depth below Earth's surface where acceleration due to gravity is same as 5 kilometer above Earth's surface. Okay. So you need to find the depth at which value of G will be same as the value which is 5 kilometer above Earth's surface. Please calculate.
So please scroll up.
Excuse me, sir.
Yes.
So what is the value of GH that we have to take?
What is the value of?
So G surface.
You tell me which value you want to take for G surface.
So
You tell me. 9 point?
9.78.
Okay, take 9.78. All
Okay,
right.
sir.
Yeah.
Yes, sir.
Okay. Everyone, please pay attention. Above Earth's surface. Above Earth's surface. So GH is equal to GS into 1 minus 2H upon RE. Right? Now below Earth surface. So GD is equal to GS into 1 minus D upon RE. Now question is saying that these two values are equal. These two values are equal. Whether you are going above or below, the value comes out to be same. The value comes out to be same. So what we can do from 1 and 2. So GS into 1 minus twice H upon RE is equal to GS into 1 minus D upon RE. It is given in the question that the value at height and value at some depth is same. GS got cancelled. So the one who was asking me, sir, what value to take, then I said, what value you want to take, right? Because of this reason only. Because GS was going to get cancelled. I knew it. So this one and this one will be cancelled. This minus and this minus will be cancelled. After that, this RE and this RE will be cancelled. So D will be nothing but 2H. D will be nothing but 2H. So D will be 2 into 5 and that means 10 kilometers. That is the answer. That is the answer. So D will be 10 kilometers. So GD is equal to 1 minus D upon RE. GS is equal to this. Because you are using only one formula. Where you are supposed to compare between height and depth. Yes. You are supposed to compare between height and depth. You are fighting at only one place. You are talking only about, in this question where you are talking about only depth. You are not talking about height. Where have you compared this depth value with height value?
So, but we calculated the value for G now in question 8 for same height.
You calculated by taking some value. As per you and your, extra hoshiari, that means you are saying that value at surface, okay, and value at height above the surface both are same, correct? Correct, no?
Yes,
That
sir.
value, that value was for that question, not for this question.
Okay, sir.
बात समझ में आ रहा है?
Yes, sir.
ऐसा कैसे चलेगा छोटू? आप अपना कर क्या रहे हो? आप अपने स्कूल टेस्ट के एग्जाम्स के मार्क्स लेके आ रहे हो मेरे को और बोल रहे हो कि सर मेरे को स्टेलर में टॉपर डिक्लेयर कर दो सर, मैंने स्कूल में टॉप किया है। मैं बोलूँगा कि देखो छोटू, वो मार्क्स तुम्हारे स्कूल के मार्क्स हैं। ऑलराइट, हेलो,
Yes, sir. Thank you, sir.
यस। आप क्वेश्चन ठीक से समझे ही नहीं। ऑलराइट, यू नीड टू रिपीट दिस क्वेश्चन वंस अगेन। अच्छा, you have got one person to appreciate your handwriting, Mr. Aradhya. Okay, so that is enough for today. We'll be talking further in the next class. Okay, everyone. Okay. Thank you so much.
Thank you, sir.
Okay.
Excuse me.
Yes.
So, when is